Welcome to the lecture series in computer science. We are seeing a series of lectures in the subject problem solving and Python programming. In today's session, we will be seeing topics from pseudocode and flowchart. The contents of the session are: we will be saying what a pseudocode is, what is the purpose of pseudocode, what are the rules for writing pseudocode, what is the keyword that has been used in pseudocode, the advantages and disadvantages of using a pseudocode, comparison between algorithm and pseudocode, and then we will be saying the purpose of flowchart, the rules for writing flowchart, advantages and disadvantages of writing flowchart, and we will as well look at the comparison between algorithm, flowchart and pseudocode. As pseudocode, what does it mean? A pseudocode is a false code. Pseudo means literally it means false. So, a pseudocode is a sort of code. It is one other way of describing algorithms. It is called pseudocode because of its strong resemblance to real program code. Pseudocode is a way of expressing an algorithm without conforming to specific syntactic rules. Pseudocode are reasonably straightforward. All statements showing dependency are to be indented. Now, let us see the rules for writing a pseudocode. We need to write only one statement per line, and each statement in the pseudocode should express just one action for the computer, and each and every keyword has to be in the capital form. So, all the alphabets should be capitalized and indentation should show hierarchy. We need to end multi-line structures. We need to keep statements language independent. Let us see the keywords suggested in pseudocode. We have keywords such as begin, end. Begin is the first statement and end is the last statement. We have input, get, read. The keyword is used to input the data. You can use either input or you can use get or you can use read to input the data. Then we have compute and calculate. These two keywords are used for calculation of the results of the given expression. We have keywords such as add, subtract, initialize. It is used for addition, subtraction and initialization. We have keywords such as output, print, display. It is used to display the output of the program. And we have keywords such as if, else, and if. These keywords are used to make decisions. We have keywords such as while, and while, which is used for iterative statements. For, and for. It is one other form of iterative statement which does the incrementer and decrementation are tested automatically. And in pseudocode, when you are writing, you are not supposed to include data declarations in the pseudocode. Let us see the advantages of writing a pseudocode. Pseudo is independent of any language. It can be used by most programmers. It is easy to translate pseudocode into a programming language. It can be easily modified as compared to flowchart. Converting a pseudocode to programming language is very easy as compared with converting a flowchart to a programming language. Let us see the disadvantage of using pseudocode. It does not provide visual representation of the program's logic. There are no accepted standards for writing pseudocodes. It cannot be compiled nor executed. For a beginner, it is much more difficult to follow the logic or write pseudocode as compared to flowchart. Let us see the difference between using an algorithm and pseudocode. An algorithm is defined as a well-defined sequence of steps that provides a solution for a given problem, whereas a pseudocode is one of the methods that can be used to represent an algorithm. Let us see what a flowchart is. Flowcharts are the diagrammatic method of representing algorithms. They use an intuitive scheme of showing operations in boxes connected by lines and arrows that graphically show the flow of control in an algorithm. Flowchart is a graphical representation of an algorithm. Programmers often use it as a program planning tool to solve a problem. It makes use of symbols which are connected among them to indicate the flow of information and processing. Let us now see the symbols used in flowchart. We have a flow line symbol, an arrow marked flow line which is bidirectional. So, these flow lines are used to connect the symbols. We have an oval shape, oval symbol or symbol is also called a shape, and oval shape is a terminal which is used to start, pause or halt in the program logic. Then we have a parallelogram. This parallelogram symbol is used for getting the input and for displaying the output. So, it represents the information entering or leaving the system. Then we have a rectangle. The rectangle is used for processing. Any kind of processing work or placed inside a rectangle. It represents arithmetic and logical instructions. Then you have a diamond symbol. The diamond symbol is used for decision making. So, it represents a decision to be made whether it is true or false. So, you need to take any sort of decision for which you have a symbol called as diamond symbol. Then we have a round symbol, a circle symbol. A circle symbol denotes connector. It is used to join different flow lines. Say for example, you have stated a flow chart which is there for some 3-4 pages put together. So, in order to have connectivity from page number 1 to page number 2, it has been earmarked with a circle sign. So, this circle, it happens to be, it will act as a connector. So, it is used to join different flow lines. Then you have a rectangle within one other rectangle. You have a parallel line among the two sides of a rectangle which denotes subprograms, subroutines or subfunctions. Subfunctions, subprograms or subroutines. So, it is used to call a function. These are some of the symbols that are used in flowchart. Apart from this, you as well have one other symbol called a cylindrical symbol which is used to represent the databases. Now, let us see the rules for drawing a flowchart. The flowchart, when you drew, it should be clear, neat and easy to follow. The flowchart must have a logical start and finish. Only one flow line should come out from a process symbol. So, this is a process symbol. This example is stated over here, wherein you have a rectangle. In the rectangle symbol is meant for doing processing. So, for which you have the flow line. Only one flow line should come in and go out of the process symbol. Then only one flow line should enter a decision symbol. However, 2 or 3 flow lines may leave the decision symbol. Say for example, if I am going to come over here and if I am going to ask a question whether I need to follow the right direction. If I am going to drive a car or a bike and if I am new to a particular place, if I do not know the direction, if I am held up in the signal, so I need to take a decision whether to go straight or move right or to move left. So, such a kind of decision you represent in the flow chart with the help of a diamond symbol. So, for which only one flow line enters as an input, and then for the output you get 2 or 3 flow lines based on the decision symbol, whether to go straight or to go right. Whether if you want to go straight, you are representing it as yes, if you are going to go it as right, you are representing it as no. So, how do you want to go? So, for that the representation diagram that is given in flow chart is diamond symbol. Next is only one flow line is to be placed with the terminal symbol. Where do you use the terminal symbol? You use this oval symbol for start and for stopping a particular flow chart. So, you have a stop. So, for which only one flow line has to come. Within the standard symbols, you need to write briefly and precisely. See, this is a oval symbol wherein you have only very limited space. So, you cannot write stories together. So, whatever points that you write, it should be on a crisp basis, and you should write very briefly and you should write precisely whatever is required. Intersection of flow lines should be avoided. So, these are some of the rules for drawing a flow chart. Then let us see the advantages of using a flow chart. First major advantage is communication. Flow charts are the better way of communicating the logic of a system to all concerned, to people whoever is working. So, flow chart, if people are going to see the flow chart, they will be in a position to note how the flow of diagram is, how it is going to represent. So, it acts as a means of communication. The second advantage of using a flow chart is on effective analysis. With the help of flow chart, problems can be analyzed in more effective way, which means if it is been shown diagrammatically, people will be able to note down where the flow goes, whether it is going on a straight line, whether any decision table has come in, and if the decision table is yes, how it goes, if the decision table is no, how it goes. So, we can do an effective analysis with the help of a flow chart. The third advantage of using a flow chart is on effective coding. The flow charts act as a guide or blueprint during the system analysis and during the program development phases. So, with the help of flow chart, by seeing the diagrammatic representation, we can able to analyze and we can able to come to a conclusion of where the error has occurred, till which line the flow has come in and where the flow has stopped. So, by seeing the diagrammatic representation, we can come to a conclusion. So, this helps in effective coding. Then proper debugging. The flow chart helps in debugging process. Then final advantages, efficient program maintenance. The maintenance of operating program becomes easy with the help of flow chart. So, if we know the flow of the diagram, if we know the flow of data, then we can definitely know where the program got stuck. So, it makes this diagrammatic representation makes the program to function effectively and efficiently, thereby the maintenance of the program will also be effective and efficient. Then now let us see few disadvantages of using a flow chart. Complex logic. Sometimes the program logic is quite complicated. If it is quite complicated, wherein the flow chart becomes complex and clumsy. The second disadvantage of using a flow chart is alterations and modifications. If alterations are required, the flow chart may require redrawing completely. Then the third disadvantage of using a flow chart is on reproduction. As the flow chart symbols cannot be typed, reproduction of flow chart becomes a problem. And moreover, rather than reproducing, supposing we are going to change any sort of design, what happens is that you need to revamp the entire flow chart, which again becomes a problem. So, it is also one of the part of the alteration modification too. Then costing. For large applications, the time and cost of flowchart drawing becomes costly. So, these are some of the disadvantages of using a flowchart. Let us have a comparative statement of an algorithm, flowchart and pseudocode. Now, what is an algorithm? An algorithm is a sequence of instructions used to solve a problem. Okay. Then what is a flowchart? A flowchart is a graphical representation of an algorithm. Then what is a pseudocode? A pseudocode is a language representation of the algorithm. My dear students, you might be able to understand the basic difference between algorithm, flowchart and pseudocode, wherein in the algorithm it is a sequence of instructions given to solve a problem, whereas in the flowchart it is the graphical representation that is denoted based on the algorithm. As far as the pseudocode is concerned, it is a language representation of an algorithm. The second comparison is the user needs to have knowledge to write an algorithm. As far as flowchart is concerned, he does not require prior knowledge of programming to draw or understand the flowchart, but he needs to have knowledge in drawing the flowchart, but the understanding of programming knowledge is not mandatory when a user is going to draw the flowchart. Then as far as the pseudocode is concerned, the knowledge of programming language is not required to understand or write a pseudocode, because pseudocode, it's after all it's a false code. It is not a realistic real programming code. You are writing you are representing the logic in the form of languages. So, the knowledge of program is not so required when we write a pseudocode. This is the comparison between an algorithm, flowchart and pseudocode. Now, let us summarize of whatever we have seen in this session. We have seen the purpose of pseudocode. We have seen the rules for writing a pseudocode. We have as well seen the keywords that are available in pseudocode. We have seen the advantages of using a pseudocode, the disadvantages of using a pseudocode. We have made a comparison between an algorithm and pseudocode. Then we went on to see what a flowchart is, what is the purpose of flowchart, and then what are the rules that are required in writing a flowchart or in drawing a flowchart, because usually flowchart, it is all of symbols type. Usually you draw the symbols and then you write it precisely within the space available inside the symbol. Now, let us see the advantages of using a flowchart. First and foremost advantage is said to be communication. The flowcharts are a better way of communicating the logic of a system to all the people, to all the concerned. All the concerned means whoever is part of this particular software development, or they require the flowchart. So, to all people, they are all called as stakeholders. Who is a stakeholder? A stakeholder is a person whoever is part of the software preparation. So, the programmers is a stakeholder, the project manager is a stakeholder, the team leader is a stakeholder, the project leader is a stakeholder, the customer is a stakeholder, the designer is a stakeholder. So, whoever is responsible for building the project, they are all called as the stakeholders. Now, so the flowchart, it becomes a better way in terms of logic. Say for example, if there is an issue in the logic, then with the help of flowchart we can streamline where the flaw is, where the defect is. So, that is said to be one of the major advantage, that is communication. The second advantage is said to be effective analysis. With the help of flowchart, problems can be analyzed in a more effective way. What does it mean? How do you analyze? Say for example, when you have a decision symbol. What is a decision symbol? A decision symbol is represented with a diamond. So, when you have a decision symbol, which means if it is of yes or no, if it is yes, you are supposed to write this set of lines of code, you are supposed to move in this particular way. If it is of no, you are supposed to move in this particular way, wherein for having this decision, how do you have the input? The input and output are represented using parallelogram. And how is the procedure being represented? The procedure is determined, or the processing of operations, the computations, the arithmetic computations, the additive and subtractive or multiplication or division arithmetic computations are placed in a procedure in a rectangle. So, within the rectangle you do all sort of computation and then come to the decision table. So, all your arithmetic calculations are being placed in a rectangle. So, here we can do such a kind of analysis, wherein in the flow chart, supposing if a flaw happens, we will be in a position to find out till where the flow has come in and where the issue has taken place, why it has not moved from this particular position to this particular position. So, what was the problem? So, we will be in a position to solve it. So, which means this flow chart, with the help of flow chart you can do effective analysis. Then efficient coding. The flow chart acts as a guide or blueprint during the system analysis and the program development phase. Only with the help of flow chart, people will be in a position to write down the code effectively. When you have a flow graph, people know, people in the sense here the programmers, the developers will come to know where the flow of data is, where the flow of direction is, how do I need to write the code, how do I need to develop the code. So, here with the help of diagram, this diagram will act as a blueprint. For example, my dear students, many people would have seen the building construction, house construction. In terms of building a house, before constructing a house, you would have had a blueprint, a plan for the house, a plan for the apartment. So, based on the plan, the supervisor, the mason, he used to construct the house. So, based on whatever dimensions that has been given in the plan, based on which the mason he used to do the construction work. Similarly, in a software, based on the diagrammatic representation that has been given in the flow chart, the programmers or the developers will be doing the coding part. So, that is the reason the major advantage, one of the major advantage of using a flow chart is on effective coding. The next major advantage of using flow chart is on proper debugging. The flow chart helps in debugging process. What do you mean by debugging? What is a bug? What is a debug? A bug is a error. A defect, then what is the difference between bug and a defect? A bug is an error which takes place in the development environment itself, wherein a defect is an error that takes place at the customer end. So, this program debugging, when you have a bug, when you have a error, you will be in a position to correct it. You need to know how to correct it. That is called as, so if you are not able to do your corrections, you immediately go to the drawing, you see the drawing, what is the fault, where the flaw is, how the flow graph is, how the flow of direction is, how the data has been flown. So, based on which you can do the effective coding and effective debugging can be done. Then finally, you have effective program maintenance. The maintenance of an operating program becomes easy with the help of flowchart. Here, when you are going to have a proper diagram and when you have written the codes with respect to a proper diagram, then definitely the maintenance would have also become easier. Now, let us see the disadvantages of using a flowchart. Complex logic. Sometimes the program logic is quite complicated, wherein the flowchart becomes complex and clumsy. What does it mean? When the program logic becomes more and more complex, the flowchart will run pages together. When the flowchart is going to run pages together, then having control on the flowchart, it becomes a problem, it becomes an issue. So, you need to have, if the flowchart is there for some 2 or 3 pages, we can have full control over it. If the flowchart is going to be there for some 25 pages and if you are going to use jump statement in between, then having control in the flowchart becomes so clumsy and it becomes so problematic. That is the reason the program logic is quite complicated, wherein the flowchart becomes complex and clumsy. The second disadvantage of using a flowchart is alterations and modifications. If alterations are required, the flowchart may require redrawing completely. Okay, when do you get the alterations? When the requirements change frequently, when the customer does not give the full-fledged requirements, when at the development end, when they do not have clarity in the requirements, then the customer, if he is going to give changes in the requirements, then definitely alterations in the blueprint has to be made. So, here the blueprint determines the flowchart. So, if the alterations are required, the flowcharts may require redrawing completely. Next is reproduction. As the flowchart symbols cannot be typed, reproduction of flowchart becomes a problem, because all flowchart symbols we do only drawings. So, when you are going to do the drawings, each and every shape you call it as a symbol. Symbol is also called as a shape. So, these symbols, since it is a symbol, it cannot be typed, it cannot be reproduced, and that is the reason the flowchart, so reproduction in a flowchart becomes a problem, becomes an issue. Then finally, the costing. As far as the costing is concerned, for larger applications, the time and cost of flowchart drawing becomes costly. When you are going to develop an application for a period of 1 year or so, 365 days or so, then it is time consuming and it is costly too, wherein when you are going to reproduce a system or when you are going to show it in a diagrammatic way, and when the requirements are going to change more frequently, then the cost of flowchart drawing will also become so costly, because when there is a change in requirement, you are supposed to modify or redraw the entire flowchart. So, in that case, the time and cost of flowchart drawing, it will become costly. Let us have a look of the similarity and difference between using an algorithm, using a flowchart, using a pseudocode. What is an algorithm? An algorithm is a sequence of instructions used to solve a problem. A flowchart, it is a graphical representation of an algorithm. A pseudocode is a language representation of an algorithm. Here in the algorithm, it is a sequence of instructions to solve a problem, whereas in the case of flowchart, it is a diagrammatic representation or it is a graphical representation of algorithms. Then in the case of pseudocode, it is a language representation of an algorithm. Then the second point in algorithm is the user needs knowledge to write algorithms, whereas in the case of flowchart, the knowledge of user in terms of programming is not required in order to draw or understand a flowchart, but he definitely requires knowledge in drawing the flowcharts. Knowledge of flowchart is essential, but knowledge of programming language to draw a flowchart is not required. Next is pseudocode. In the case of pseudocode, knowledge of programming language is not so required to understand or to write a pseudocode. So, when you are going to write a pseudocode, it is only a false code, so for which the understanding of knowledge is not required. Let us summarize of whatever we have seen so far in this session. We have seen about what a pseudocode is, what is the purpose of using a pseudocode, what are the rules for writing a pseudocode, what are the keywords that are used in a pseudocode, what are the advantages and disadvantages of using a pseudocode, how do you compare algorithm with that of pseudocode, what is the purpose of a flowchart, what are the rules for writing a flowchart, what are the advantages and disadvantages of writing a flowchart. Finally, we saw a comparative analysis between an algorithm, flowchart and pseudocode. In the next session, we will be seeing with respect to examples of an algorithm, flowchart and pseudocode. We will take a real time practical example and then we will try to resolve how an algorithm to be written, how a flowchart to be drawn, how a pseudocode has to be written, and as well we will see how the algorithms are analyzed. So, these things we will see in the next session. In this session, we have seen the basics of pseudocode, flowchart and the difference and the comparison between pseudocode, flowchart and algorithm. Thank you.